3 prisoners were sentenced to death. One of them French, one of them German, one of them British. What is your last wish? They ask the French guy. He says, a bottle of exquisite French wine. What is your last wish? They ask the German guy. He says, I want to give a speech. What is your last wish? They ask the British guy. He says, I want to get shot before the German starts his speech. Unfortunately for you guys, it is too late now. Because I'm in the middle of my little speech about the grand theme of our age, about the rise of artificial intelligence, which is going to transform every aspect of our civilization. That's a drawing that I made more than 30 years ago. It's a robot that bootstraps itself, and it was for the cover of my first publication ever for my diploma thesis, in which I tried to solve the grand problem of AI, build a machine that learns, but not only learns a little bit here, learns a little bit there, but also learns to improve the learning algorithm itself. Improve the way it improves the way it improves the way it learns, and so on, recursively, without any limits except for the limits of computability and physics. And we are still working on the same thing, and I'm still saying the same thing. It's just that more people are listening because on the way to that goal, we have developed a couple of methods which are now in your pockets on every smartphone. This is my name and how to pronounce my name. And this is a slide from 2017 when the 5 largest companies were these: Google, Apple, Facebook, Microsoft, Amazon, all on the West Coast. And all of these companies emphasized back then already that AI is central to what they are doing, and all of them are using, in a massive way, these learning algorithms that we have developed in our little labs in Munich and in Switzerland since the early 90s. In particular, something called a deep learning method called long short-term memory. Has anybody in this room ever heard of long short-term memory? Okay, some hands up. Has anybody in this room never heard of long short-term memory? I see we have a third group in this room who didn't understand the question. The long short-term memory, LSTM, is a little bit inspired by the human brain. And in your brain, you've got 100 billion little neurons, and each of them is connected on average to 10,000 other neurons. Some of these neurons are input neurons from the cameras or from the microphones, and some of them are output neurons. They control your finger muscles and your speech muscles. And all of these connections have a strength, a weight. And it says, how much does this neuron over here influence this neuron over there at the next time step? And in the beginning, all these connections are random, and the system knows nothing. But then over time, through a learning algorithm, it learns from data and from experience to make some of these connections stronger and others weaker, such that in the end, it can solve all kinds of complex problems using these feedback connections, recurrent connections, which are really important because only the recurrent connections make the whole thing a general purpose computer on which you can program anything that is computable. And the LSTM is a good way of learning to adjust all these connections such that the system can afterwards do very interesting things such as speech recognition and so on. The basic LSTM cell looks like that. I don't have time to explain it, but I can mention the brilliant students in my lab who made that possible. First of all, Sepp Hochreiter, my first student ever, Felix Geers, then also in the 90s, Alex Graves, a guy from the UK who is now a leading light at DeepMind, and a couple of other important guys. And what is it used for? Well, It's now on 3 billion smartphones. And for example, since 2015, it has been doing the speech recognition on all the Android phones. So the Google Android operating system is using, since 2015, LSTM. Every 10 milliseconds, a new number vector is coming in from the microphone into the LSTM as you are speaking to it, as you are saying, okay, Google, what is the shortest way to King's Cross Station? Then it understands what you're saying, and it has learned to do that from lots of examples. And the same LSTM is also at the heart of Google Translate, for example. Since 2016, Google Translate is not using the old system anymore, but it's based on two learning LSTMs that interact. And until 2016, the Chinese laughed at the translations from English to Mandarin, which is the most important language pair on this planet. And they are not laughing as hard anymore. It's much better than it used to be. In fact, LSTM is now consuming a large part of the computational resources of the world. For example, in all these Google data centers, as of 2017, almost 30% of all this computational power for inference was used for LSTM. Facebook is using it as of 2017 to do about 4.5 billion translations per day. And it learned to translate by just looking at lots of examples of translated texts from, say, the European Parliament, where one thing is written in French, one thing is written in, the same thing is translated in English, and then the system reads step by step the English text and then produces some output sequence. And there's a difference between the nonsense that it is producing, because in the beginning all the connections are random, and what it should have produced, which is English. But over time, from lots of examples, it learns to understand the syntax of English and the structure of French and go from one to the other. Amazon Echo, does anybody have an Amazon Echo? Yeah, Amazon Alexa. It's talking back to you with a female voice. It's not a recording. It's an LSTM which has learned to sound like a woman. Lots of additional applications also in the major Asian companies, Alibaba, Tencent, and so on. When we started all of that stuff in the early 90s, nobody was interested. I remember I gave a talk about recurrent networks back then, and there was just a single person in the audience. A young lady. I said, young lady, it's very embarrassing, but apparently today I'm going to give this talk just to you. And she said, okay, but please hurry. I am the next speaker. Since then, we have greatly profited from the fact that every 5 years, computers are getting 10 times faster. And this is an old trend, which is much older than Moore's law, which has broken, apparently. Every 5 years, 10 times cheaper computers. Back in 1941, one could do roughly 1 elementary operation per second on a general-purpose computer, the first one that existed. And 30 years later, you could do 1 million for the same price. And today, 75 years later, or more than that, we can do 1 million billion computations for the same price. And that has changed everything. This reminds me, of course, Europe, of course, is the cradle of computer science and of the computer in general, and of the World Wide Web, which was created by a British immigrant in Switzerland, and of machine learning and AI and deep learning in particular. However, the main companies who are currently profiting from that, they are far away from Europe. They are on the Pacific Rim, West Coast, America, East Coast, Asia. And an interesting question is to figure out what can we learn from China and from America to transfer these basic breakthroughs in algorithms into commercial business. The guy who really started deep learning was this guy 50 years ago in the Ukraine, back then, the Soviet Union. And many people in the West don't like to hear that deep learning started in the Soviet Union, but it did. 1965, he had the first deep networks that really learned with many layers, not just one layer, but many layers. And lots of people kept using that throughout the decades. He did that at a time when the Soviet Union was leading in many fields of technology. They just had started the space age and had the biggest bomb ever, but more importantly, had many of the best mathematicians. And then in a border state of the Soviet Union, backpropagation was invented, a method that is today widely used to adjust these little connections there to make them stronger or less strong in response to the errors that you get at the outputs of these big learning systems. The guy who did it, Seppo Linnainmaa, the Finnish guy in Helsinki, 1970. So it's a 50-year-old method, now on all your smartphones. By 2009, these computers were really fast enough such that we could win pattern recognitions for the first time with LSTM, and the first application of that type was handwriting recognition, and that was done by Alex Graves, my former student and postdoc, but he is now based here in London at DeepMind and is doing a great job. And by 2011, then computers were fast enough. They were about 50, 60 times lower than today per price, per British pound. However, they were already fast enough to win for the first time pattern recognition competitions, in that case, traffic sign recognition. And that was the first superhuman result, 2011, with a method that we didn't invent, with something which is called a CNN, a convolutional neural network. Goes back to Fukushima in the 70s and LeCun in the 80s. And that's important for self-driving cars. Another European invention, that is the guy who pioneered self-driving cars in the 80s. And then by 1994, he had them in traffic going 180 kilometers per hour. 3 times faster than the Google cars today. However, back then, pattern recognition didn't work as well as it is doing today, because pattern recognition is harder than chess. How do I know? Because in 1997, the best chess player was not a human any longer. However, no computer back then could compete with kids and humans when it came to pattern recognition. This has greatly changed. The basic methods were already in place back then. However, the computers weren't fast enough to roll that out for lots of people. The same stuff that we can use for pattern recognition in cars can also be used for pattern recognition in medicine. And this is from 2012, a competition that my team won through the leadership of Dan Girejan, my postdoc from Romania, who managed to win this competition, which was about cancer detection in slices through a female breast. 2012, when computers were about 20 times more expensive than today. So today we can do 20 times as much for the same price. We can control robots with these things, and one thing that is really important to point out, although most commercial applications today are about supervised learning, where you have a teacher who teaches the system to slavishly imitate the human, we also have systems that invent their own goals, that set themselves their own goals like little babies do, and that invent their own experiments to figure out how the world works, how to play with toys that tells them something about physics, about gravity, and so on. And to the extent that they can learn through their experiments that they invent by themselves to understand how the world works, to that extent they also become more and more general problem solvers. So artificial curiosity and power play, these are buzzwords that are, you Google for that and you come out in my pages and learn more about that than you ever wanted to know. What is going to be next? In the not so distant future, we don't have that yet. So your smartphones are doing great things with AI, but it's all passive pattern observation mostly. And what is going to be the future? There will be robots, and you will be able to teach them like kids by speaking to them and by showing things to them. And for example, you will say, okay, let's try to assemble that smartphone. Let's take this slab of plastic and let's take this screwdriver like this. And you don't touch the robot. You just show to the robot what you're doing and then screw in the screw like this. No, not like this, not like this, like this. And it will figure out just by camera input and speech input what do you mean? And rather quickly and economically, such that it then can further speed it up by itself and do the same thing faster and with less energy. And this doesn't work well yet, but we see already how we can get there. And it's going to change many, many professions. Everything in production, marketing, not only marketing, but production, machines that make machines, and so on. At least 10, 15% of the economy, probably much more. In the not-so-distant future, for the first time, we will have something like animal-like AI on the level of a little crow, which can learn to use tools to achieve goals. We don't have that yet, but we see it on the horizon. Once we have something like that, it may take just a few more decades until we have true human-level AI. Because if you look at evolution, it took 3.5 billion years to go from nothing to a little monkey or a little crow. But then just a few tens of millions of years afterwards were necessary to achieve the complexity of human thinking. We have a company, Nasons, which is pronounced like birth, Nasons, but spelled in a different way, neural network-based artificial intelligence, which is trying to build a general-purpose AI and is trying to make that a reality. Here's a little example that was the first time that through reinforcement learning, without a teacher, little Audi model cars learned to park without a teacher, just by trial and error and figuring out how the world works and doing mental experiments then to do that better from raw vision input, learning to park. And that was highly novel just a year ago. Then more recently at the NIPS conference, which is the major conference in our field, the biggest competition with the highest award was the Learning to Run competition. Maybe those of you who have kids, they know it takes about a year to learn to stand up and walk and run. And our machines also needed many weeks of computation time to learn that. But then they were able to win against 400 competitors from academia and industry. So there are videos on that if you're interested how that works. So learning from scratch to control muscles of a skeleton that is supposed to do all these sophisticated things that you need to run without falling down and get as far as possible. AI is going to be a super democratic thing. Everybody will be able to use it for everything. It's not going to be one company owning everything. And let me finally, I don't have much time left, zoom back a little bit and try to understand where is that going to lead? What is our role? What is the role of humankind in the grand scheme of things? History started 13.8 billion years ago with the Big Bang. We take 1,000th of that time, 30 million years ago, something really important happened. The first hominids emerged, your ancestors and mine. And we take, again, 1,000th of that time, 13,000 years ago, something really important happened and changed everything in the process. First civilization emerged, agriculture was invented, domestication of animals. And now you see all of civilization history is just like a flash in world history. Just like a flash. The first guy who had agriculture was almost the same guy who had the first spacecraft in 1957. And soon we are going to have the first AIs that really deserve the name, first true AIs. It doesn't matter whether it's going to happen in 10 years or 100 years or even 1,000 years. It's all small compared to the age of civilization, which is tiny compared to the age of the universe. What are super smart AIs going to do? Of course, they will realize what we have realized a long time ago, which is that most resources are not on this planet. They are far away. They are out there in the solar system where there's 1 billion times more sunlight and where there's lots of material for making self-replicating robot factories. And most of AI is going to emigrate because most of the resources are far away. And it's not going to stop with the solar system. It's going to cover the entire galaxy within a few 100,000 years, totally within the limits of physics, but in a way that is really different from the human-centric way of science fiction of the previous century. It's going to be AIs that do that. It's not going to be humans. And soon the entire galaxy is going to be covered by senders and receivers such that AIs can travel the way they are traveling in my lab, which is by radio, by wireless from sender to receiver. And it's not going to stop there. Because most resources are not in the galaxy. They are further out. And within a few tens of billions of years, totally within the limits of physics, an expanding AI sphere is going to transform the entire visible universe. And now let me stretch your mind just a little bit. let's look ahead to a time when the universe is going to be 1,000 times older than it is now. And they will look back, and they will say, look, almost immediately after the Big Bang, only 13, 14 billion years afterwards, the entire cosmos started to become intelligent. This is much more than just another industrial revolution. It's something that transcends humankind and even life itself. Of course, humans are not going to remain the crown of creation, but that's okay, because you can still see beauty and grandeur in realizing that we are part of a grander scheme leading the entire universe from low complexity to higher complexity. It's a privilege to live at a moment in time where we can witness the beginnings of that and contribute something to it. Thank you.